Stay up and
Okay, well, I can stay up there.
I've got plenty. Good morning. I'm Evan, K9SQG, and I'll be your moderator this morning. We've got some seats up front here and in the middle if anybody needs some seats. And is everybody having fun today, or is there anybody here that's not having fun? Okay, security will see him out in the alley in a minute. Okay, the theme of this year's forum, or should I say the Hamvention, is internationally connected. And I think Hamvention is one of those things, along with our military, that foster international connectivity. So let's just give our active duty military and retired military a round of applause. And as you know, we wouldn't be here today if it weren't for them defending our freedoms and so forth, and we really appreciate all they're doing on our soil as well as overseas. And I'd like to express thanks to the Hamvention staff for providing this facility for us to use and for the Hamvention in general. And if you see any of the staff out in the flea market or any place, thank them for all the efforts that they're doing. They're all volunteers, and it's really the labor of love. I'd like to thank also the people that made this forum possible. There's Mark, WB0IQK. He's our IT expert. We've got Gene, W8KXR. He is right at the back. If you don't have a prize stub, we've got a free prize drawing. Go see Gene at the back there. He's got the black hat on there. And all the prize contributors, Ron, WB4HFN, is going to be making a presentation, and he donated things like a pair of 6JB6 tubes, some interface cables, a step start, got some gift certificates, and we appreciate that from Ron. And Jeff, WA8SAJ, donated a family affair book. And Kurt, W0ALC, donated a couple of Drake TR22s or TR22Cs, I believe it is. Ham Gadgets has a interface, so there's a lot of interesting prizes there and so forth, so you won't want to leave before the prize drawing is over. We're going to be drawing the prize stubs during the presentations, and then at the end we're going to announce who the winners are, and you can pick up your prizes in the hallway. We're trying to free up the room for the next people, so pick up your prizes in the hallway. And I'd like to thank in particular Mark, NAPEP, and Aaron, NAQID. There are videographers and editors at the back corner of the room, and we will have a presentation available on the internet for this year's presentation as well as last year's presentation. Before we get started, let's just take a pause to remember our friends that are not here this year because they're silent keys. Okay, gentlemen, we'll get the presentation started here. And we're going to be having presentations about the L7, bringing it into the 21st century. We've got a presentation by Ron, WB4HFN, about the L4B tabletop linear. We're going to talk about resources that are available for the Drake enthusiasts. Rob Sherwood is going to be talking about some PTO problems and fixes for the Drake line. We'll have the free prize drawing, and then we'll have a question and answer session at the end there. In terms of bringing the L7 into the 21st century, I'm sure a lot of you are available or have this available to you and have used it or else you've seen it. Let me just do one check. Can you hear me at the back of the room without the microphone? Okay, fine. The L7 is really a fine amplifier. It covers 160 through 10 meters. It covers the work bands and just about everything in between. It's really a nice amplifier, but it's nice to be able to make it compatible with new rigs and so on and so forth. The PTT compatibility has to do with how much current and voltage the transceiver can sink. And some of the newer transceivers have limitations either with the FET switcher or with the reed relays that are in there. The older rigs don't have that particular problems, but it is a problem with the newer rigs. There's some parts that are either unavailable or they're extremely costly to replace. You either have to have them custom made or buy a junker and replace them and so forth. With regard to the L7, you can damage the PC capacitors. There's two capacitors that are made out of thin PC material. One's the plate tuning pattern, just for 160 meters, and the other one is a part of a trap on the RF choke. They're good, they're inexpensive and so forth, but if you have high SWR or some nearby lightning strike, you can puncture those capacitors, and once that happens, they're pretty much not usable. The 3500Zs have been going up in price every year, and anything you can do to extend the life of the tubes is certainly a positive thing. You want improved reliability, whether you're a contest or a net operator or whatever. You'd like to make sure the amp is there when you need it. And also with regard to preventative maintenance, we're talking about amplifiers that are 30 to 40 years old, and everything has a lifespan. So anything you can do to extend the life of the amplifier, it's money in your pocket. What's the downside of doing an upgrade? First of all, there's high voltage, and the 3500Zs are high vacuum tubes. You tap the tube with the end of a screwdriver or pliers or something like that, it'll send shards of glass everywhere. So you want to make sure you either wear glasses or safety glasses if you're going to be working around them. And also, with regard to the high voltage that's present in there, if you're not familiar with high voltage, if you've never worked around that equipment, this is probably not a beginner project for you. In terms of adding parts, the more complex a piece of electronics is, the more problems you have with reliability. But what I'm going to talk about, there's so few parts that are going to be added, it really doesn't affect the reliability significantly. Maintenance-induced faults, it really gets back to how skilled you are and so forth, and how much of a rush you're in and so forth. And you don't want to go in there and create problems that weren't there before the modifications. With regard to some of these upgrades, most are not visible from the outside. If you're a purist and you want everything to look the same, maybe you would want to think about which ones you want to do and which ones you don't want to do. Some of us have installed the Heathkit shop board or the Harbach electronics board for a little different configuration for the filter capacitors, the diodes, and the ALC and bleeder resistors. Last year I talked about some of the mods to the power supply, adding the handles, an internal fan there, and some larger feet on the bottom, and that's available online and so forth. The soft key PTT line, the one that I use is by Ham Gadgets, and they're a prize contributor today. After you install the PC board, the PTT line will have 7 volts DC, and you have to sink 15 mils to get it from transmit to receive back and forth and so forth, which is something that all the modern rigs can handle. I mentioned about the soft key also, that's available from Ham Gadgets. That's a sort of a generic or wide use interface that has multiple applications, and here it works real fine for the transmit receive line. To do this, you have to take out the 10-meter low pass filter, which isn't a big problem. We try to use some of the original wiring to the extent possible to save rewiring the whole harness and so forth. This is the Ham Gadgets interface, and in terms of increased part count, you've got a bridge rectifier, you've got a capacitor, you've got the optical isolator, a couple of diodes and resistors. So you're really not adding a lot of parts in terms of reliability. And this particular board has some of the components left off, the ones that are not essential for operation. You don't need the LED indicator lights. If it's underneath the chassis or in the back where you can't see it, having the LEDs there doesn't really buy you anything. This is where the power supply components are mounted for powering the interface. This is slightly different from the L4B. The L7 is a little bit more crowded towards the rear apron, so you can't use the same technique for the L7 that you would on the L4B like I talked about last year. So this is basically, this is the area where the low-pass filter was for 10 meters. That's been removed and replaced with just a straight length of coax. This is a 100 mil pigtail fuse that I put in the circuit. I just like to protect everything. It's a cheap protection. And then there's a dropping resistor and a Zener diode to bring the voltage down. This is the soft key with the cables connected to it, ready for installation. This is the soft key that's installed through a right angle piece of metal there. And you can see here's where the low-pass filter was, where it's got the pigtail that you just wire in the circuit. A short length of RG58 or RG58U works fine. This is the power switch there, and to avoid problems with shorts and so forth, the board itself is anchored pretty well. It's got a piece of insulating foam on the back so that it doesn't touch any of the ground or RF wires that are there, and also a little dot of RTV silicon rubber to prevent it from falling in contact with the power switch. But I can't imagine that ever happening because it's mounted on a right angle piece of metal that's not going to bend very easy, but I'm sort of compulsive in terms of safety and things like that. This is the lead routing from the interface board. It goes through the harness and so forth over to the changeover relay, and here's the power supply components. These are some thermistors that I installed in the primary of the filament transformer. They add a little bit of current limiting during a power up, and it saves the tubes. And they have to be mounted in such a way that there's a clear airflow around them. That shows the basic technique. There's a insulated standoff there that is used to put the thermistors in series with the filament transformer. For the plate transformer, I did the same thing there. A slightly different arrangement because of the configuration of the components. I had to put little strips of PC board strips from terminal strips that I just cut to size there, and then mounted the thermistors over there. With regard to the fans for the L7, that's been a persistent problem with me until I got the problem solved. I don't know how many problems. How many people have had problems with the fans on the L7? Anybody here? Okay. The problem with the fan is that eventually they wear out. They're a sleeve-bearing fan, and they have a certain number of hours of use and so forth, and based upon temperature and a lot of other factors, they have a lifespan. This is the original fan. I found a substitute for it that I got from 3 or 4 different sources. These were brand new fans, same part number, with the exception that they're ball bearings rather than sleeve bearings. So you'd think, well, that's going to last a lifetime, and one would think that, but what happened is Nidec, Rotron, Torin, there's been a number of buyouts over the years and so forth, and somewhere along the line, near as I can gather, they changed the lubricant on the fan. So the new fans, when I started using those replacement fans, they were fine, and then as the years went on, I found out that the fans would fail after about half an hour's worth of use. And what would happen is that it would actually seize up. It was sort of evasive trying to find that. I thought maybe the thermostat had failed. I thought there was a problem with the wiring. I was going through all these things. Having put a new fan in there, I figured, well, it couldn't be the fan. Lo and behold, it turned out to be the fan. So if anybody wants a new fan that has ball bearings that's going to seize up after a half an hour, see me afterwards. I'll give you a real good price on those. And the thing that's really disappointing about this is when you take a look at the part numbers on the fans, you'll see identical part numbers, but it was manufactured at a point where, and again, I think they cheapened up the lubricant, and it seizes because the heat from the 3500s is pretty intense, and that lubricant just can't handle it. At least that's what I conjecture. So I found some different fans, and basically if you get one that's the right size, pick a 115 volt fan that has about a 110 mil current draw or something like that, and it'll work fine. I changed the series dropping resistor to a slightly lower value to increase the speed and the slow speed. What that does is it gives you added cooling in the slow speed, and it also delays the point at which it switches into the high speed. And generally when I operate, it rarely goes into high speed. Was there a question, sir?
I was going to say, how do you place that resistor with the thermistor so it would be automatically adjusted?
Interesting. So it's just as needed then. That's an interesting approach, a little more sophisticated than mine. So if you're going to do a fan replacement, I've got some spare fans. If you need some, you can contact me for them. But generally, I pick ones they're 110 volts and they're about 110 mils. And if you can, double check to see if I'm reading on it. Replacing the PC board capacitors with doorknob caps is something that I did because of some RF decks that I had serviced, and I don't know all the causative factors that cause those PC capacitors to fail, but they're not as robust as some other capacitors, shall we say. So on 160 meters you can run into a problem because that's the band where you frequently have problems with high RF voltages and so forth because of antennas that have high SWR and so forth. If you have a nearby lightning strike, that could cause a failure, or maybe those capacitors fail just on the basis of age alone. These are the capacitors here. This is the one on that forms part of the trap on the RF choke, and this is the patter for the plate tuning. The plate tuning patter is used just on 160 meters, no other bands. This is what the capacitors look like after they're removed, and it's actually fairly flexible PC material. I don't know what the breakdown voltage is on it, and it was probably a cost basis why they picked this particular design, and I just like to increase the reliability by replacing those before they fail. This is the one of the capacitors. This is for the patter for the plate tuning. It's a 300 puff 16 kV doorknob. I added a little bracket for mounting here and a solder lug there. I didn't want to buy capacitors from overseas. I like to buy American, but the price difference, we're talking about something like $14 from Ukraine or Bulgaria or whatever, versus something like $45 to $55 American made. So it was just a cost thing. This shows the mounting of the capacitor here. It's got the right angle mount there, and then you just wire it into the original wiring. There's no change in the length of the wiring, and it's a nice, neat installation. This is the, you can use either a 47 or 50 puff. The original capacitor was a 47 puff. I could not get a 47 puff high voltage doorknob at any reasonable price worldwide. So I went with a 50 puff, and it seems to work fine. And I made a little bracket here and a solder lug there, and that shows the installation through the top bolt there, and then there's a soldered pigtail down there. And now we're going to talk about a redesign of the L4B linear by Ron, WB4HFN. He configured the L4B to be a tabletop amplifier with integrated power supply, and it's going to be an interesting presentation. He's going to give us the ins and outs of doing that. Ron?
I can attest to the fact that Evan is right when he says high voltage is lethal. What do I do with this?
Don't point it at your eye.
I'll point it at the person who boozed me. In any case, I just got out of the hospital 2 weeks ago, spent 2 days in there because the Collins Power Supply didn't want me to touch it. So 1,000 volts in my case wasn't lethal.
Thank goodness.
Yeah. Evan told me I have to talk fast because if I run out of time, he's going to throw something at me. Which reminds me, I was born and raised in Louisville, up the road here. At age 42, I was transferred to a foreign country called New England. Up there where my first day, my first staff meeting, I learned how to talk fast now because when I talk slow up there, my employees told me, said you could I could take a coffee break in between words. So I rebutted by saying, so why do New Englanders try to put an entire sentence into one syllable? So we kind of got down to a median. I don't talk slow, but now that I've retired, I'm living in Tennessee, I have a chance to slow down both physically and verbally. So anyway, what my presentation today is on an L4B modified. I had a customer who gave me an L4B chassis, which was pretty much empty, had a few of the components on it, but I decided rather than scrap it for parts, I was going to rebuild it. It's been a lifelong project of mine, just something to do. Not if I've got plenty to do, but I put this in between repair work and everything else. But this is the original L4B with the fan, the two tubes. This is the completed L4B, which I'll go through. It's basically a power transformer, power supply with a single tube. Okay. Next slide.
Turn around.
Huh?
Turn around.
Oh, good. All right, just a little history on the L4B. The L4B first was introduced in 1965 and ran through about 1979 plus or minus. The first L4B did not have the watt meter built into it, and it used a pair of 4-400s. The later version had the built-in watt meter, and then when it came out to match the C-line, they got rid of the chrome edging. The matching power supply runs roughly around 2,400 volts at an amp. Typical failures are dried out filter capacitors, the load resistors open up, and when the load resistor opens up, high voltage goes too high, it has a tendency to arc to the roof and then blows the fuse. Alright, so this was where I started. This was the blank chassis. I took out everything and even the tube back here and left one tube. Then I made a steel plate, or that's an aluminum plate, and I riveted to the bottom to cover the hole in the bottom because this is where the power transformer is going to go. And the only thing that was left there in original is the filament transformer on the sides. And then where I took out the blower in the back, I made another steel plate, aluminum plate and rivet that to the back to cover up the holes. And with that, I was able to mount the power transformer, and I moved the plate choke from that hole over to there. And this is a plate transformer out of a Heathkit SB220. It fits in there perfectly. It's a little heavy, and it produces about 200 more volts in the output, but it fits in there real good. I moved the plate choke over, and I had leads long enough, and the power supply was going to go in here. And then down on the bottom, you know, like you have the tune and the sideband switch, which is the red switch. They're switching primary voltage, but so what I did here, I put a terminal strip in the bottom, right in here, which not only allows me to either operate it at 110 or 220, I also put a relay here to actually go from tune to SF to single sideband. And that is controlled with the red switch in the front. So now a relay is switching to primary power, and I'll never have to worry about destroying that switch again. Okay? The 8-pin plug in the back that plugs into the high voltage power supply, I now made that my primary power. And it's wired I can either wire that plug, depending on how I wire the plug, for 110, 220. And I put a separate fuse switch here, and then there's another fuse on the other end of the chassis for the high voltage. So it's powered with two 10-volt 10-amp fuses. And then this is the original version where the power watt meter is here, antenna changeover relay, and of course the capacitor, the feed-through capacitors. Well, I wanted to get rid of this whole relay and come up with a sealed relay. Of course, that's a little bit bigger. So what I ended up having to do, I took out the capacitor, these big feed-through, and replaced it with just some disc capacitors across and then to ground on either side. Put the relay in there, but as you can see, this watt meter board, which would be right here, I turned 90 degrees and mounted it to the back. Now this gave me plenty of room to put the relay in. So that was the next phase of it. Then after I put that in, I went and put the tank circuit back in and the plate tuning coil and put the meters back in. And then I created, I had to come up with a different method of mounting the doorknob capacitors. So I made this little bracket, and I made a little bracket that came off and went over to the coil here. And then I put the meters back in. My goal was to make this externally look 100% like an L4B, but inside it was a single tube, self-contained. That's why I call it the all-in-one. All right, after I put that, now the power supply, I chose to use the Heathkit shop high voltage replacement circuit board. That's what that looks like now. It's if you put one of those in your L4B, they're great. Hardbuck makes the same thing. They're both about the same price, and they're both very good. I put the Heathkit supply in here, and everything is on a single board. Everything. So I mounted that, as you can see, like here. I mounted it right. The second final tube would be here, so I mounted that right up against the wall, right on the inside. Three screws fit perfect, and I made a little bracket for the fourth one. And then you can see over here, this is where I made the other bracket, brought it down, and the wires from the transformer went right in, so it all fit in just perfectly. Okay. Fan-wise, even with one 3-500, I ended up installing this. This is a high-velocity fan, 12 volt. I just mounted the tube itself will be right here, so it's blowing across the tube and out the side. And the resistor network, you know, the 4-5 meg resistors, I brought it from there, went down between the power transformers in the back of the plate tuning and grounded it over there, put a control over here for mounting with, so I could adjust the high voltage on that. Okay, there you go. The one problem I had going with solids, with low voltage relays and everything, is that when you went from transmit to receive, the 24 volt changed enough that the fan speed changed. And then my next slide, you show that I got away from the neon lamps in the pilot lamps and went with low. And I noticed that running it at 24 volts through a dropping resistor, that the brilliance of the lamp changed. So what I ended up doing, I created this is the original 24 volt circuit here, which drives the relay, but I've got a 12 volt regulator here, and then this is the switching that switches the relay here. So I built a little 12 volt regulated circuit, and that regulated circuit powers the fan and the lamps, so that when you go from transmit and receive, you don't see the fan speed changing and the lights changing. Okay. So what I did for the lamps, this is the original lamp and this is the 12 volt version. What I did, I just hollowed out the back of it. This is the original. I just took a little hot glue, a little drop of hot glue, and ran it's a 12 volt lamp that has leads on it. And I just put the 12, a little bit of hot glue and sat it down in there. And if it ever goes bad, you can break it loose and it'll come right out, but it'll hold it safe. And it looks very, very nice. Okay? So this is the amplifier after I completed it. By the way, I didn't have switches, so I went on eBay and found the switches. And somebody listed the switches on eBay just about the time I needed them, but he wanted a small fortune. So, I mean, if you wanted, you paid the price, so I did. Anyway, those switches alone, I think, were like $100 a quart or something on eBay. But,
That's correct. That's what we are.
yeah. But anyway, my goal was achieved. Everything looks original from the front. Okay. On the inside, again, it's the power transformer that I put in on the SB200, the power supply, plate transformer, and the single tube. Okay. On the bottom, you know, the power supply, the watt meter was turned 90, board was turned 90 degrees, the antenna relay, the rebuilt power supply, and as you know, I got rid of those feed-through capacitors and I used just some 01s to filter it out, and it works fine. The power switching relay and the power and the programmer for 110 or 220. Okay, so in conclusion, the high voltage power supply amplifier, my goal was to make it look like original. About the only thing I did, I eliminated one of the final tubes, took out the large power transfer, the large blower, put in the power transformer. The results, I use it every day. If anyone's heard me check in on any of the nets right now, I use that amplifier because I just moved to Tennessee and my ham shack is still in boxes, so I've got in the repair shop, I've got one transceiver and the L4B amplifier. So if you've heard me on the air, that's the amplifier I'm using. The results, one tube works fine, the loading and tuning works identical. I had no modifications, no problems making that tune. It's virtually in the same place it would be if I had two tubes. I'm getting about 200 volts more out of the power supply, but the power supplies from Heath Kitchhoff or Harbach, it works fine. So what am I getting? I need about 80 watts of drive, and I'm getting roughly about on 80 through 20, I'm getting about 750 watts out. I'm driving it with about 80 to 90 watts. And on 10 and 15, I'm getting between 600 and 650. Like I said, the amplifier's been on the air several times, and I'm quite proud of the project. It came out, it looks real good, and everyone I've shown it to says that it looks great. So for me, that's my L4B right there. Okay, I want to talk about some hints and kinks. I've still got time?
We're out of time, Ron.
We are. Can I go through this real quick?
Real quick.
All right, let me just do this. Hints and kinks, just go to the next slide. If your amplifier stays keyed all the time, check this right here, because if those short to ground, it'll key your amplifier. That's the pilot lamps. Next one. Remember, under the bottom, the fan blows down. It creates a pressurized chamber that blows up through. If this gasket goes bad, you lose your pressure. I use weather seal and the hardware store. Okay, you know about this resistor right here. That's the fuse resistor. If you lose high voltage, next one. If it burns, like this. I cleaned it up, and I use hot glue and just form around there, and that pretty much takes care of all the insulation. Next one, never ever ship an amplifier with tubes in it. Here's two different amplifiers that I received. This is what it looks like, and it didn't break the tubes, but it actually will break the pins off. Okay? Never ship your tubes in a horizontal position, always in a vertical position, because this is American made, and they riveted at the top, and it was hanging on, and I went this, boom. So a good tube went clunk. Always ship them in the vertical mode. All right, for packing. Always pack, when you pack one, make sure it is well packed and it doesn't move. If it moves, there's something wrong. Don't use the plastic styrofoam peanuts. What happens when you take a brick and you drop in a styrofoam peanut? Same thing happens. I received one styrofoam peanuts. I had 200,000 flat peanuts. All right, next. Go to the next one. Go to the next one. All right, my last point that I wanted to make is that there's a new source for parts off of eBay. But would you pay $476 for an NN4? They usually about $125. Some of the guys are now taking perfectly good things off, and they're selling them. Next slide. If you add up all the parts off of eBay, you pay $476 for an NN4. So, next one. Preventive core, buyer beware. Know who you're buying from. Read the seller's feedback. That's extremely important. Make sure you can get an exchange of money back guarantee, and make sure that the shipping is reasonable. That's my presentation. Thank you.
Thank you, Ron. We're going to be talking about resources here in just a moment, but let me just mention one of our big prize donors was Kurt W0ALC. There he is, donated the tier 22s there, and we certainly appreciate that. We're going to talk about some of the resources and so forth. Sindre Tor, where's Sindre? He'd like to make just a very brief announcement about a website.
Thank you, Evan, and hello, everybody. Yeah, I'm now building up a new virtual museum for Drake on the internet after my friend passed away last Christmas, and the former virtual museum has been closed down. And you're welcome to visit the new Drake Museum at drakemuseum.com. I repeat, drakemuseum.com. It's under construction, so please be patient with me. And it's going to have a lot of new stuff and information. Then the old one didn't show up. And if you have any info, pictures, and so forth that you think others would like to see on the web museum, please send me an email, and it probably will be on the website. So that's all. So welcome to visit the new web museum at drakemuseum.com. Thank you, everybody.
Thank you, Sandra. We appreciate it. Gene, have you made the prize drawings?
We can do that. We're going to have a tell me to put your hand and stick it in. We're going to draw from that. We're going to take those numbers and put them on a clipboard here. And shall we announce the number?
Yes, if you could do the pick the tickets out now, Gene, and then as soon as you're done tabulating those, bring them up, and I'll announce them. And remember, you pick up your prizes in the hall there. Let me just mention some of the resources that are available to the Drake enthusiasts. We've got the Drake Technical Net on Sunday, and Mark's going to be hosting that tomorrow. We've got the Drake and Antique Tube Gear Net Tuesday night. And then there's that Family Affair book, and Jeff W8SAJ was kind enough to donate one of those books to us here. And then there is the Drake Reflector. Incidentally, all these slides and so forth are going to be made available at Ron's website and so forth, so you don't have to write down the information. We will provide that to you. Donnie Garrett provides a variety of replacement parts for the Drake, the noise blanker, plugs and cables and pots and things like that. That's a very good site. Fred and Mike are out in the flea market. They're at 73cnc.com. They make custom knobs for Drake, Elecraft, and so forth, as well as a higher capacity heatsink there. These are some of the inserts and so forth that are available from Al Phillips, who was not able to come to Hamvention this year. Radiolab Works makes some LED direct plug-in bulbs. the solid state LEDs, that is, for the PTO lamps as well as the meter lamps. These are some modules that are available for the AUX7 board if you have one of those and you want to program them. Rob Sherwood has a variety of products, and he's going to be our next presenter. And there's a lot of useful filters and information and receiver test results and so forth at his website. Ron's website, wb4hfn.com, has just a vast line of resources there, including free downloadable manuals. And I keep going through there several times a week, and I'm still not done with all the content. I think Cindy just talked about the new website there, and Drake's one of the largest, if not the largest, Drake collector in the world. And there, he just mentioned about Drake Virtual Museum is the previous website, and his current one is drakemuseum.com. Tom Acosta at K3HRN is at zerobeat.net, and there's a email and a reflector available through him. The CDs are available from Gary K4OAH. He's got a lot of useful information and pictures that's not available elsewhere, and it compares the various variants of the R4C, R4B, and so forth. Bob offers some service kits if you're interested in servicing the TR7. Mike Bryce is out in the flea market. He makes AC4 retrofit kits as well as the power supply upgrade boards for the L7 and L4B. Hayseed Hamfest. They don't, Tom's not here. He had, his wife's in the hospital and was unable to attend. He's got a useful direct replacement capacitors for the AC4 supply and AC3. Jeff, WHCQ, is out in the flea market. He has a variety of resources available for the Drake enthusiasts, the power supply boards, and so on and so forth. Ham Gadgets donated a interface board. We had presented that last year in terms of the capabilities of that interface board. These are some other resources, and again, you'll be able to get this information online. And now we're going to have a presentation by Rob Sherwood. He's going to talk not just about some challenges or problems with the R4C PTO, but something that's going to fix some of those things as well. Rob?
A couple years ago, I talked about cleaning up some of the line-related sidebands on the PTO, but it wasn't a total solution. But you may not all have been here, so I'll include some of that from this time. The interesting thing was the PTOs, in the late TR7s, they put a grounding braid on the PTO, and actually I ran into this issue with my original R4 back in about 1965 that my father bought for me, and I found a little ground strap helped, but then many decades later it was incorporated. So you can get the details obviously on the web, but this work was done by Don. So this is just sort of a pictorial. You can use solder wick, and here's a real picture. Now this is obviously an R4B with the chassis color, and you can see the little braid in there. And here's from the other side, there's the braid. And this provides a better ground, because really the ground's often just provided by this spring, and this spring kind of corrodes over time. So Drake actually did this in the TR7 at one point. But one of my clients had sent a R4C in and have some work done on it, and he was very sensitive to the tone of the cleanliness of the CW beat note, and he says he said it had hum on it. Well, it really wasn't hum in the way you think of a power supply hum, but it was actually on the sidebands on the PTO signal itself. So he said, you've got to fix this, or I just can't listen to it anymore. And it ended up being a grounding issue that was part of the solution. Now this is the PTO. I had a spare one. I just put it on the bench, powered it with 12 volts, and 10 volts actually. And this is a spectrum analyzer, and you can see it. They're just super clean. So there's nothing wrong with the PTO itself. So then the question is, what was going on? And this was his radio, and you can see that hum side bands were only down 24.6 dB, and this gave those, this non-pure note, and that was what was really bugging him. So this is when I did some extra grounding. You'll see in the picture what I did, but here it dropped it down. Before it was 24 dB, and it dropped it down to 37, so he was happy with it, but it still had more stuff there than you'd really like. So here's what I did here. This is fairly simple. I tried new metal, and that didn't do anything, and I actually replaced the transformer. I thought maybe the transformer was bad. So this is the hole that's already there. I tapped that with a 632 tap, But if you don't want to tap it, you can use a 440 screw. So that's just a solder lug, and I soldered it on there. And that made this shield, that shield snaps on there on both sides, has a little spring thing. So that just meant that was a better ground, because over all these decades, there's a little bit of corrosion, and that's apparently what was wrong with the radio that I was working on. But then it came to mind that there was still something going on, and actually another ham mentioned that it had to do with the transformer field. Now here's a picture of an R4, and that's what I had back when I was in high school. And if you look at the transformer from the back, you see the end caps. You don't see the laminations. And here's an R4A, which was just a slight update. It had the solid state PTO in the R4A versus the 6AU6. And you can see the back of it, it's got the end cap. You don't see the laminations. And here's an R4B. This isn't a great picture, but you can see it's the same deal. You can see the end cap here from the back. Now here's the R4C. I have no idea why it was turned 90 degrees, but you look from the back and you're looking at the laminations, which meant, I guess, the hum field was totally different and wasn't canceling out. So now the question is, how practical is it to turn this 90 degrees? So here's the picture of my R4C with it before we did the rotation of the transformer. And in mine, it was down 31 dB on the spectrum analyzer and all this stuff here. So actually I told my technician to do it. So he took it all apart. Those are the original holes, the big ones, but they don't have to be that big. And he's used a 9/16, just a little bit bigger than a 1/2 inch chassis punch. And he punched 2 more holes in here. And now here's the transformer rotated. You see, now we're looking at it from the back. We see the end cap. We don't see the laminations. And so here it is after the change. It went down to 49 dB. You can just barely see them down here. And that's the measurement on the 60 hertz. And then the 120 hertz is down 68 dB just by rotating that transformer. So if you really like that clean note that the R4B had, you can make your R4C. And that takes about maybe an hour or 2 to do this mod. You have to take out the fuse holder temporarily so you can get the punch in there. So it takes some time, but that was really a nice way to clean it up. So just quickly, you can go to our website if you want to see kits we've been offering for all these decades. It's kind of amazing that with all these people still enjoying their radios, and it's great to have the direct equipment still functioning.
Thank you, Rob. Appreciate the presentation. Okay, gentlemen, now we're going to announce the prize winners. I'm going to read off the numbers of the prize winners, and then I'm going to pass this back to Gene so he can put the stubs on some tickets. If we run out of prizes, if anything happens, see me afterwards, and we'll make sure we square with you. The winning prize numbers are now the last 3 digits only. 905, 905. The next one is 045, 045. Next one is 907, 907. Next one is 029er, 029er, then 982, 982, 947, 947, 022, 022, 002, 002, 976, 976, 983, 983, 9er, a lot of nines, 9er. We've got 020, 020, 9er, 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 013, 013, 016, 016, 9er, 8, 9er, 8, 027, 027, 017, 017, 9er, 34, 9er, 34, 021, 021, 9er, 9er1, 9er, 9er1, 039, 039, 038, 038, 9er, 81, 9er, 81, 033, 033. And I'll give this back to Gene, and he'll put these on the prizes. If we run out of prizes, please see me in the hall, and we'll make sure we square with you. Okay, now we're going to open up the floor for our question and answers. We have some Drake experts here. We've got Ron at the back of the hall. We've got Jeff, WA8SAJ, Bob, W4WTO. We've got some other experts here. Do we have any questions that anybody would like to ask of the experts? Yes, sir, in the back there.
Evan,
I believe it does. I would recommend anybody that has those PC capacitors to replace them. If it's for the L75 or the L7, I would recommend that, just because the doorknobs are designed for high voltage and high current RF applications, and they're just more robust. A lot of people have had good luck with stock capacitors. Other people have had problems, so it's at individual discretion on that. Okay, any other up front here? I can't address all those modes, but I can address the modes that I use, which is primarily sideband. Everybody's got their own way of tuning up the amplifier, as not just the L4B, the L7, but other ones and so forth. I personally find some of the instructions in the Drake manual a little bit vague and so forth, and particularly when you want to talk about legal limits. So I'll just describe for you what I do. Other people may be able to chime in and say what they want to do. I always tune up in the sideband position. I always leave it in high voltage. I do not use the CW position. The switch was put in there back in the days when you had to have one input for CW, one for sideband, and so forth, which the levels are lower. And I find it's just too much hassle, and it doesn't really benefit you. So I always tune up in the sideband position. And then what I do is I put the rig in a CW mode, and I use a tuning pulser. You can do the same thing with the keyer and just put out a series of dots, dip the plate, and adjust the loading and the plate tuning capacitors, and just keep on increasing until you get approximately. I use somewhere around 900 to 1,000 watts peak, and then I hit the solid key to do the final tuning and so forth. And I just leave it I tune it for a maximum output, but keeping the limits on the grid current at about 200 to 220 mils, 565 mils on the plate, and that's the procedure that I use. I do not tune up in CW and then go to sideband and so forth. And I tune up in sideband position. I operate it in the sideband position. I tune for maximum power output, keeping within those limits. And then I back off the mic gain control when I want to, to keep the power down and so forth. I don't operate at maximum power input or power output. Does anybody else have a technique for the way they tune up? Or Don? No? Anybody else? Ron? Oh, okay, okay. Were there were other questions? Yes, sir. Yes, if you go to Ron's website, wb4hfn.com, there's an article about that rebuilding process. There's pictures and so forth, and several people have gone through that process. You just want to be careful and meticulous and so forth. Springs can fly all over, but yeah, that procedure works good. Yes?
I installed W8ZR's switch, solid state switch.
Okay, Tom had mentioned there's another article out, W8ZR. Jim has a procedure whereby he uses a solid state module to control the high current, if you will, and the surges and so forth on the primary, and then the switch on the front just takes very low current to operate it. Ron?
I just want to let everybody know another resource for great parts now is Walmart. If anybody breaks the globes around the 3-500, go to the sporting goods section and get a cone clamp globe. $6.95, and they fit.
Let me just modify Ron's statement there. I have used those globes and so forth. Be aware there are two sizes of globes. One works, it's identical, same size in all dimensions. The other one is too large. So, and some people have said, oh, when you replace it, you have to change the clips and so forth. That's only necessary if you pick the wrong size globe. Then yes, you have to change those clips, reverse them, and so forth to accommodate the larger chimney. But if you pick the right size, it fits perfectly. Don?
I have an application where I have an R4C. I'm using a microprocessor. I'm counting the carrier oscillator output. And I'm counting the injection oscillator output. So what I do is I take that and I'm able to determine the frequency, and then I drive an ICOM radio. So I'm using the receiver as a receiver, and I'm using the ICOM as a transmitter. The problem I'm having is on 160 and 80, for example, the injection output is about half a volt peak to peak. By the time I get up to 10 meters, I've got essentially no output. I mean, the signal I'm getting looks more like noise. What should that output level actually be? Or do I need to send this off and have someone repair it? I mean, I just soon do that, but it works fine except for when I get to 15 and 10 meters. The injection output is just too low that it's just all.
Sure. Jeff or Rob, have you?
Do I answer that first? Oh, it's made to work with a T4XC or T4XP, not an icon.
No, but
But
what I'm saying is
Yeah, the level will be down.
right, but what should that level be?
Don't know exactly. Oh, it is quite low. Using RG62 cable.
No, I mean, I've tried everything. I've
But have you
very
tried
high pitch load on it.
RG62?
It works fine on the
Does
lower
it work
bands.
okay with a T4XC?
I'm not using a T4XC.
No,
All I
have
is
you
one
tried it with a
receiver.
T4XC?
No, I don't have a T4XC. All I have is a receiver.
I know, but
And I have I'm taking a very high, I know, but I'm taking a very high impedance load.
not maybe we've done that.
Yeah, I have to second what Jeff says, that output is sensitive to loading, and you do need a low capacity cable. I can work with you, Don, because I've got the complete C line and then the cable, so forth. Let's, we can see if we can get that going for you. Okay. Ron?
Yeah, I was going to say, I've done some experimenting with that cable. That's 39 pins. And you've got to make sure that when you tune them that those is matched together. The signal level is only about 30 or 40 millivolts, so it's fairly low. If you have good power output on 80 and 40, but you lose a lot of power on, you start going down on 20 and very little on 15 and 10, it's your cable. Not having the proper impedance, or there's something wrong with the cable, it's very typical to lose a lot of power on 10 and 15, and it's usually that injection cable.
Okay, fine. Thanks for that comment, Ron. Other questions? Yes, sir.
I noticed you had the picture of those large heat sinks on one of your slides.
Oh, for the plate caps, perhaps? Uh-huh.
I'm concerned, I had an L7. I was concerned if I put those in, the high voltage spark to the top cover.
I think that there's enough clearance, but you want to double check that to make sure. To be honest with you, I'm not sure if I would use those plate caps or not on the L7 from the L4B. The reason is that in the L4B, the blower pressurizes the plenum, the air comes up through the tubes, and then out through the cabinet like that, and the pins are arranged vertically. The L7 has a different cooling system. They have a fan that pulls the air out the back, it draws it in from there, so the air is actually moving horizontally, not vertically. So you might see a minuscule difference in the plate caps, but I would just, if it were me, I would try it out, but be very careful and make sure that there's enough clearance, because you're dealing with 2,500 volts there, and yeah, if it's marginal or close. I think that there will be enough room there, but I would double check to make sure on that. Okay. Were there other questions? Yeah, Don?
I just have a comment.
Sure.
You all know that Drake has been out of the amateur market for a long time, and they had been, as of recent years, their primary business was satellite television. If you ever stayed in hotels and you saw, LodgeNet, for example, that was the Drake system. Well, you may not realize this, but Drake has been bought up now by Blonder Tongue, and the Franklin operation is going to be shutting down very quickly. So Drake is going to be a thing of the past. I mean, Drake isn't going to exist. It's now Blonder Tongue, but just,
Okay, sort of the final chapter of the Drake history.
It's sad.
Yes, it is. Yes, it is. Any other comments or questions from anybody? Thought I saw another name.
I got one.
Yeah, Mark, go ahead.
We're set up outside, and there's been, 2 or 3, maybe 4 people come by about wanting to know where to repaint the cabinets. Hartzell is not doing cabinets anymore, guys. So you're going to have to start doing them yourself. There's a couple people that'll repaint them. If you want to do it yourself, there's procedures on Ron's webpage to do that. So,
Mark needs a sideline.
Mark's got a lot of experience repainting Kenwood cabinets as well as the Drake cabinets and so forth, and he's got some very interesting procedures there, and also the paint. There's a particular, was it Krylon or Rust-Oleum? Krylon paint, and it's a dead, match for the original Drake, and I just painted some cabinets recently.
I don't know who put this recommendation up on the website, but when spraying the cabinet, you have sort of that bumpy effect from some of the later Drakes.
Mm-hmm.
The idea, I think someone said drill the nozzle.
Right.
That does work great.
Good to hear that. Yeah, Mark's the one that's responsible for that. That's good to hear. Or Ron's responsible for that?
Well,
Okay.
Ron and
Okay. Any other comments or questions? Anybody? Okay, that finishes the form for this year. The prize winners, please go out to the hall. And for those that don't have prizes, you have it stubbed, see me afterwards. Thank you.
There's the unused ones.